Now let's just talk about the question number 2. It says prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. So let us suppose if I'll draw a rhombus over here, and I'm just taking this as nothing but A, B, C, D. Let us suppose this is A, this is B, this is C, and this is nothing but D. Let us suppose if I'm joining their diagonals. So this is the diagonal and this is the diagonal. So let us suppose if these are the diagonals, then what we have to prove over here, that let us suppose I'm calling this as nothing but O. So let us suppose if I'm starting with the proof, what we have to prove over here, we have to prove that the sum of the squares of the sides of the rhombus means AB square plus BC square plus CD square plus DA square is actually equal to AC square plus BD square. This is the thing that we wanted to prove. So let us suppose if I'm talking about the given statement. So we have given a rhombus that is A, B, C, D, A, B, C, D, and A, B, C, D, and the diagonals, we have the diagonals which are B, D, and A, C, bisecting each other at O. So since we know that the diagonals of the rhombus actually bisects each other, so it means they are forming an angle of 90 degree over here. So if they are forming an angle of 90 degree, let's just start with the proof of this particular question. So as you can see in the triangle AOB, so let us suppose if I'm talking about in triangle AOB, what can we say about this? That AB square is actually equal to OA square plus of OB square. By the Pythagoras theorem, we can say about this fact, this is nothing but the Pythagoras theorem, that the square of the hypotenuse is actually equal to the sum of the squares of the other two sides. So this is my hypotenuse. AB square is nothing but is equal to OA square plus OB square. We can write this by the Pythagoras theorem. Now further, as you can see over here, they are bisecting each other. So if they are bisecting each other, it means that OA is actually half of that of AC. OA is actually half of that of AC. So we can write in place of OA as nothing but it is half of AC whole square. Similarly, we can write OB as nothing but it is a half portion of the total BD square. This is nothing but a half portion of total BD square, because since we know that AO is nothing but a half of AC, and similarly OB is nothing but a half of BD. So hence, using this particular fact, we can say that AB square is equal to AC square by 4 plus of BD square by 4. Now further, if I'll take the LCM over here, we can say this as 4AB square is nothing but AC square plus of BD square. Now from this particular thing, we can write this as nothing but 4AB square. We can write AB square plus AB square plus AB square plus AB square exactly at 4 times, which would be nothing but is equal to AC square plus of BD square. And since we know that in the rhombus, all the sides are equal to each other, we know about this fact, the properties of the rhombus, that all the sides are actually equal to each other. So it means that if we have AB over here, then in place of AB I can write BC square, in place of AB we can write CD square, in place of AB we can write nothing but AD or DA square. So this would be nothing but AC square plus of BD square, and that's what we have to prove over here, that the sum of the squares of the all side is equal to the sum of the square of its diagonals. So let us suppose if I'll write a fact over here that AB is equal to BC is equal to CD is equal to DA. So using that particular concept, I have proved this thing. So hence proved this thing that the sum of the squares of the sides of the rhombus is equal to the sum of the squares of its diagonal. So you can also take it as a theorem, because this theorem can also help us to prove other questions and theorems as well.